So your second exam is coming up, and it's going to be a lot like your first exam, where you're given 3 questions and 90 minutes to answer them. So in this video, we're going to be doing just a small review of the topics that you can expect to see, but there are also practice problems on the Mastering Engineering site that you can use to practice with and see what types of problems are going to be on the exam, as well as a full solution key that I've written that will be on the D2L. So there's a handwritten solution on the D2L, and your Mastering Engineering offers the problems for you to work yourself. Again, that's not graded or anything, it's just available for you to practice. So the concepts on this exam are going to be everything we've done since the last exam. So it's not cumulative, even though the concepts do kind of build on each other. I'm not testing you on any of the material we've already done in exam 1. So where that starts is with moments. So you're going to need to know how to take a moment, right? Both in scalar and vector. So knowing that a moment is a force times a distance, right? Knowing how to do right-hand rule with a moment, where you stick your thumb in the direction of the axis and then you use the curl of your fingers gives you the positive rotation. Right, so we usually assume that counterclockwise is positive. So knowing how to take a moment scalar form, knowing how to do a moment in vector form as well. So the cross product, R cross F, finding a position vector that links your point that you're taking the moment about to force vector, and knowing how to do that cross product. That we usually do the IJK, your Rx, Ry, Rz, your position vector is always the middle one. And then your force vector is always the last one in this cross product. Now this is given to you on your formula sheet, but it's important that you know how to use this and when to use this. So you have your moments as well as a moment about a specified axis. So, say for example, you want to take a moment about the z-axis. Knowing that the moment about an axis, you use the unit vector of that axis and do the dot product of that with R cross F. So knowing how to utilize those things. And then the last major concept in moments would be understanding what a couple moment is, what that means, and how it's applied. How it's applied when you're finding your equivalent moments, your equivalent forces, when you're adding things together. So understanding what a couple moment is, and that a couple moment still uses F times D, right? So the perpendicular distance between them and the F of just one of those forces for a couple moment. I'll also ask you about equivalent forces. So these were when we had a system on a body or something and we said, all right, find the equivalent force using your sum of your moment equation, sum of your x and sum of your y forces, and then being able to find the position of that resultant force, right? So when you're finding that position of the resultant force, say it's, here, for example, how do you find this distance d? And that again is by taking a moment. You'll use the y portion of this distance, or this force here. The y portion of the force times the distance. If you had found a moment about this point, you can use the moment about that point, the y component of the force, and then the distance d is what you're given when you do m equals fd, so d equals m over f. Understanding equivalent forces and how we find those. I'll also ask you, either explicitly or implicitly within another problem, about distributed loads, right? So understanding that a distributed load how to find the resultant force from that, right? So you have some beam and you've got a distributed load on it. How to find that resultant force and how to find where that force is acting. So your resultant force, we said, is just the area under the curve, which you can find with the integral of whatever this equation is that they give you. Usually we call it Wx, the load equation. W of x, knowing that that's an integral, you are given this equation, but knowing how to do this integral, and more importantly, where it acts, right? So it acts on the centroid of the shape, which you're given via x bar, integral of x, wx dx, over integral of wx dx. So understanding how to use these two equations where appropriate, right? The integral portion, I'm never going to give you a tough integral with like sines and cosines or multiple. It'll be a simple integral because I'm not testing you on how good you can do integration. It's whether you understand of how to apply this integration concept into a distributed load. It's also good to know you are provided a chart for these, but it's also good to know that a distributed load that is triangular in shape or rectangular in shape acts in a certain place. So we know that we can calculate the area of a triangle. So FR for a triangle, 1/2 base times height. FR for a rectangle is just the base times the height. And then where it acts within those shapes that we often see. So in your rectangle, it acts halfway through the rectangle. And in your triangle, it acts 1/3 from the tallest side of your triangle. 1/3 of the way in. Again, you are going to be given a table for these standard shapes, but these are the ones that we saw most commonly in the problems that we worked. They would be good ones just to have in your noggin. You'll also be asked about equilibrium equations. We spent a good amount of time talking about equilibrium, right? Equilibrium of a body. So in 2D, that was where we had some of our x forces is 0, some of our y forces is 0, and some of our moment about a point is 0. And then in 3D, we had 6 different equilibrium equations that we were applying, right? Some of the forces in the x, y, and z direction, and then moments about the x-axis, about the y-axis, and about the z-axis. So understanding the differences between 2D and 3D and how to apply those equations. How do you take a moment about an axis? How do you set up all of these equations? A huge chunk of the points of these are going to be setting up free body diagrams and the equilibrium equations. So even if your algebra messes up, that's worth a very small amount of points compared to can you actually set up the problem correctly. You are going to be given these equations, but it's knowing how to use them that is important, right? You need to know the steps to solve these equilibrium of a rigid body problems, right? So one thing that I won't give you for these is the reaction forces themselves. So you will need to know if you're given, say, a pin, right? A pin in 2D or in 3D, that a pin has reaction forces in the x and y directions. Or that a roller has just a normal force type reaction, right? Just one in the y direction. Or that a fixed reaction, right? A fixed reaction, say against a wall or something. At a fixed reaction, you have the y, X, and a moment reaction. Right, so you have all three. So those are important to know, as well as the ones in 3D. So 3D, a ball and socket is really the major different one. A ball and socket constrains in all three force directions. X, Y, and Z. And then your fixed support now constrains, instead of in 3 directions, it will be in the X, Y, and Z force directions, but also moments. Moment about the X, moment about the Y, moment about the Z. And we use right-hand rule for these 3D ones to determine correct positive direction. So knowing how to apply the right-hand rule here, knowing what the reactions look like at these standard supports here, that is something that you will need to know. It would also be very helpful if you can identify two force members. I won't ask you to explicitly, but it might help you solve some problems. The final topic on exam 2 is going to be the most recent one, and that will be truss problems. So you'll likely see a truss, but you can use either method of joints or sections. I don't care which method you prefer. You get the same answer either way, whether you want to use method of joints or method of sections. I won't ask you to use one explicitly over the other. It's your preference. I just want to know that you are able to solve a truss, right? You're able to follow the steps of looking at a truss, identifying these zero force members, so the identify zero force members, solve for the reactions, solve for the forces within the members themselves, and then whether those members are in tension or compression. So those are the major things that I'll be looking for in a truss. But again, method of joints or sections, totally up to you. So those are the major topics. You again have a formula sheet already for you on the D2L, as well as all the practice problems. So these should be able to set you up for success as you're studying for this exam.